let's talk about Chapter 13. This is ways you can attack other users. And so we'll start with these slides and then move to the demos. All right, so request forgery is a big one. Now, request forgery is also called session writing. This is where you trick someone into taking an action they didn't intend to take. And you don't enter their account and perform the action on their behalf. You trick them into doing something without realizing they're doing it. So you never have to collect their session token. You simply trick their browser into making an unwanted request. So here's an example of it. If you go to this page, let's get rid of this garbage. I don't like either of those choices. All right, so here's a message board. I can have a question and a name and a message, and when you submit it, you get a page, okay? And you see up here, I have a message, how to hack this, and that message appears down here. So it looks like I could do document object model injection there, but I think if I try it, it's not gonna work. Script, alert 1, script. Let's see if this works. And see, it doesn't work. Now you might wonder why it doesn't work, so let's inspect this. And you'll see, it actually has a less than sign there. It's in a TD tags. So I'd say it's not obvious to me. I thought it had replaced it with ampersand LT semicolon, ampersand GT semicolon, but it hasn't. But it's still sitting there and it doesn't run, which is a little strange. Anyway, I don't know why that didn't run, which is troubling, but let's go back anyway and try the attack that actually works. We're going to put this in the type field. Let's see where the type field ends up. If I run this, let's find out where the word question appears. Here. The question is an image. So you put in the word question, and that, I think, and that appears here. Question.ping. Let's try that, verify that by putting something else in other than question. Let's put in question 2 and submit. Yeah, now the image is unreadable, and that's because now it's question 2 inside there. So I can put something inside an image source tag here. So what you can do is put in this in the type field. The type field is just supposed to be a question or something else, and instead you put in code. All right, and the start of this is going to be a PHP script. All right, so it's going to put an image source tag, is going to point to a PHP script with a token, and here it is, new user called with a result. So it did call it and execute it, and so if you look at the source code for this, it now loads an image, which is a PHP script with parameters. So simply loading the image on the page will run the PHP script. All right. And I don't know why the simple injection didn't work, but anyway, that's what's called a on-site request forgery. I have injected code onto a site, and when people view that site, it now has an unexpected effect on that site. So if the administrator viewed this page and they had the privilege of adding a new user, they would run the script and create a new user. That's the simplest case on-site request forgery. All right, so you have a stored cross-site script vulnerability, and then when people view the page, it executes an extra activity which they didn't intend to perform. All right, and so that's the one here. We've been through that. And this is what I thought. According to this, the reason the cross-site scripting didn't work is because less than and greater than are being HTML encoded, but they didn't look that way in the source code, so I'm not quite sure what was going on there. Anyway, you put this in the image tag, and as we see, it will now perform a new user creation when the administrator views it. So to prevent it, you have to validate user input, restrict type to only valid values, filter out special characters. HTML encoding them would not stop this attack. This did not use any special characters, like less than or greater than. All right, and the one you most hear of is cross-site request forgery, where you create a website, and it sends the user's browser, tricks the user's browser into sending a request to a vulnerable application. So you might visit a blog, and it will then make a request to buy a book at Amazon, which would only have effect if you have another tab of your browser currently logged into Amazon, but a lot of people do. So I'd make that request. All right, now the same origin policy does not prevent websites from issuing requests to a different domain. For example, you can load a picture from a different domain and that will work. What you can't do is get the response from the other domain. So when you make the request, the response will not appear in the browser. You won't know what's happened. It's a one-way activity. You can execute a script though. All right, and therefore you can't do a multi-stage attack with this attack unless you find another vulnerability. However, that's probably even better from the viewpoint of the attacker. You buy the book, and then whatever the next page is that says, congratulations, you bought the book, you won't see it. All right, so administrators can make a new account with this one, real name equals staff, and so on. If they make a post request to this script called new user step 2, and all right, if you can just trick it into making that request, then you'll execute that function. So if the request performs a privilege action and it only requires the cookie as authentication, then an attacker can determine all the required parameters. And so you're on my blog, but the fact that you're logged in at Amazon means when I send a request to Amazon, your browser will send the Amazon cookies, which I never see and I never steal, but they authorize your request. All right. All right, so here's your trick administrator into viewing a page, and it submits the form. So here you have a series of parameters and document forms 0 submit. So it defines all the parameters with all the fields hidden and then submits it here in a script tag. That's an example of a CSRF attack. This happened to eBay. You could make a crafted URL that would make a bid on an item from a third-party website from an image tag, just like the one I showed you. So simply viewing the item would cause a bid on it. All right. So the fundamental flaw here is that the cookie is all the information you need to authorize your request, and the browser sends the cookie automatically, so you approve it and authorize it without understanding that. All right, web interfaces of DSL routers, people usually don't change anything. So your web page can log in with default credentials to get a session token, and then perform an important action like turning off the firewall. That's an example of an attack you could perform on people's home networks. So to prevent this, you should have something else besides an HTTP cookie, like a hidden field, to prove that they actually logged in on a previous page to get in, and the token would not be predictable. That's a way to do it. All right, and so here's another one that people talk about. If you look at a series of links on a page, the ones that you've clicked recently will change color if they're in your history list. And there are various attacks that would read your browser to determine what kind of links you've been on. They can generate guesses, including the token, and use this get computer style to see if that link has been visited. This is one possible way to do it. I think browsers have some countermeasures to this. This was being used a while ago. They would try like 100 websites that are common websites, like porn sites, and they would then use this technique to use JavaScript on a page to read what color browsers links would appear on the page and tell what you've been at. And then they pop a box saying, we have detected you going to this site, and you have to like pay us money to make us shut up or something. All right, so an anti-CSRF token will prevent just a PHP script running because the cookie alone will not be enough information to verify the user. It would also need to see the hidden field on a real Amazon purchase page, which would have to be one of these parameters, and you can't get that parameter because you did not actually load the real purchase page. All right, so you can defeat these things by cross-site scripting if you don't use anti-CSRF tokens. All right, so let's try a Kahoot. That's a pretty miserable project. Since everybody's always logged in as administrators, students are constantly destroying it. And that hosting service does not let me have an image-based backup to restore it easily. So I can fix it, but it'll take a while. There's nobody that gives you Windows cloud images that are worth anything. Linux cloud images, I can store an easy backup and restore them. Anyway. I'm not sure there's an easy way to make an image in Azure even. Microsoft doesn't believe in imaging systems anymore. They think you should do everything with a deployment server, which is ridiculous for individual machines and small business. Anyway. All right. All right, so which one of these will prevent CSRF attacks? That's what hidden fields do. The same origin policy does not help you. A web page is allowed to reach out to another page and execute an action. They just can't see the response that comes back. All right, which attack requires a stored cross-site scripting vulnerability? That's on-site request forgery. In the example, I think cross-site request forgery might too, but maybe not. All right. No, I guess not. I guess you could just send someone a link and they would click it. Okay. But it couldn't get on the site without stored cross-site scripting vulnerability. I guess it couldn't be on-site without that. That's what makes sense. Okay. All right, which method of authentication causes these CSRF vulnerabilities? Yep, that's the problem. If the cookie is all the authentication you need, then it's automatically included in every request. All right, and what was the Sammy worm? That was on-site request forgery. It was an attack on MySpace that affected what happened on MySpace. All right. All right, so another one is UI redress. This is a fancy name. It's a pretty clever trick too, and it works on cell phones too. They call it clickjacking, and I got an example of that here. But it looks like this. What you do is you show them a page like win big, click to win, and there's an invisible page on top of it where you're confirming something like a funds transfer. And I got an example of that with UI.html here. If I can get to there. Yikes. There, UI. There. So here, you click this button, you'll win an iPad. This is what happens when you can see it. So this one, you win an iPad. This one, you get hosed. And if you go down, here's what it looks like. Here's the evil page. And, all right, that's for this one. There's an iframe showing this page. And here, I have win an iPad, and it's kind of faded. And there's that bad thing behind it. You can sort of see it. This is cross-site scripting. You can determine the opacity of something. So now, this is the bad thing. You get hosed. And the bad thing is presented on top of the good thing with 10% opacity. And you can make it 0% opacity. Now, the only thing you see is win an iPad. But when you click, you're actually clicking the button saying you're hosed. So this is, that's how it works. They call it UI redress. All right. Anyway, people are pretty worried about this. They've been talking about it for years. All right. So that's the game. And they call it browser in the browser attack, another one where you have a page that looks like one thing, but it's really something else. All right. Another thing you can do is steal keystrokes. You can get people to type into a page, type in your name and address to win a prize or something, and then you can grab certain characters and pass the keystroke events to the target interface. So you can get them to type a sentence, and you can pick certain letters out of the sentence and get them to type somewhere else where they didn't mean to. You can get the user to perform mouse actions, like dragging elements, where they're playing a game, dragging something around, and then they're actually sending it to a different page where it shows you selecting text and dragging it into an input field. They call this frame busting is a way to defend against this. What you can do is you can put a header in the page where your page will refuse to be loaded in an iframe. An iframe is where you load an extra part of a page in a page, like an ad. And it's part of most of these UI redress attacks. So you can prevent this, where you cannot run in a frame. And what it can do is try to bust out of the frame. That's the defense here, where when the page is rendered in a frame, it tries to break out of the page, out of the frame, and go to the main page, where it can't be sitting invisibly on top of something. So in 2010, a Stanford study found that all the frame-busting defenses could be circumvented. So here's frame-busting code. If top location is not equal to self location, that means I'm in a frame. Because self, I think, is going to look in the frame in the document object model. I'm not quite sure. I think top is the real page, the heart of the page that matches the URL up in the top of the browser, and self is this object's location. And if they're different, then you're in a frame. So if that's true, then move this up to the top. And I may have top and self backwards. You have to read a JavaScript manual to find out which way it is. But that's the defense. If you control the top frame, the user can redefine top.location as a variable under their control. This is overloading. You can define a variable that is already defined by JavaScript, and your new definition will override the old one. So then you can trick it. You can also hook the Windows on before unload event. So when it tries to run the frame busting code, they'll have a different event handler blocking it. That's why the problem is if you're inside a page, the attacker controls the JavaScript, and they can change the meaning of the JavaScript you try to add to break out of it. Top level frame can define the sandbox attribute. That'll disable scripting in the child frame, but its cookies will still be there, so the attack will still work. And you can use a Internet Explorer cross-site scripting filter to disable the frame busting script. This is using a defense against you. You can use the browser's attempt to block cross-site scripting to block the script that was going to escape. So, all right, those are some of the many techniques to overcome that defense. So the way to prevent it is to use the XFrame options header. This has been added for this reason. You can, when you put a web page up, you can specify in the header whether you want to allow this page to load inside an iframe or not. And you can just block it so nobody can put your page inside somebody else's page and have the JavaScript for your page run in a possibly hostile environment. This is similar to what a lot of people do. They do not let deep linking of images happen. They host images, and you can make a page without their ads and just put their images on your page, and you can put headers to prevent that, where your images will not load on anybody else's page. And mobile web pages are one place where these UI redress hacks happen, and they often lack these defenses, but And you can do it on mobile pages, and you can load those mobile pages in normal browsers. So there is some risk there. All right, the same origin policy, as I mentioned, is so that if you send a request to another domain, you can't see the response, but there are tricks you can use. You can inject formatting HTML, but not script tags into the response. Let me see if I can understand this one. Okay, form action. I'm going to forward an email with some hidden fields. And then down here, I'm going to add a stat tracker ID in a variable. All right. All the shaded text is treated as a single URL and sent to the attacker, including the anti-CSRF token. All right, but how did I get it here? But how did I get it? Well, down here I defined a script, stats tracker ID. No? I'm afraid I don't understand this one. Okay, I don't quite understand what they're doing there, but I know there's one like this that you can do in the Web Security Academy that's easier to understand, where you inject code that actually steals a field off the page to fill in the anti-CSRF token. So browser ignores the second form tag and sends the request to the attacker. All right. Yeah, I think the point of that was somehow to get data from the other site by having a form inside a form. And I don't quite understand exactly how it works. In the Web Security Academy, it'll be more clear. All right. So if the application blocks less than and greater than, if you can reach the subject line of an email, you can put in a subject line like this, which is going to implement CSS. And what that will do is the entire email will be interpreted as CSS. And the response will be in the font family property, including the anti-CSRF token. This one I can understand. All right. And so you host a page on your own domain, including the response, and you query the definition with JavaScript. So here, you load from the email page, and you write this stuff with the font, and you fetch the font family. So you trick it into defining a CSS field, and then you can read what the CSS field is. I understand it only in general terms. All right. Then there's JavaScript hijacking. You can load JavaScript from another domain and use it. This is commonly done. Usually you don't put anything sensitive in the script, but some sites do use JavaScript in strange ways. So if you log in, click Show My Profile, that page contains a Show User Info script, and which it dynamically loads containing a script with your personal information in it. Then the script can get user data and make a function call showing user info. I can make a page that loads the same script but defines a different function called show user info. And if the login user views the malicious page, it will collect the profile and put it in a pop-up. This script defines a script with this source, and this alert X, it's going to show user info and then alert what it the X. So I don't quite understand how the X gets loaded from the script here, but it does. And again, I think it would be more clear if we see it in the Web Security Academy. All right. Hurricanes and weather effects I don't know anything about that, Warrington. Never heard of weather being changed by microplastics. I guess it might affect rain or something. Anyway, all right. So here's some attempts to prevent this. You can use anti-CSRF tokens, as we talked about before. You can poison shared JavaScript with bad code at the start, so that when you load the script, you root the bad code, but other people can't easily use your code. You can only allow code to be loaded via post requests. And HTML5 lets you have full two-way interactions if you give permission in HTTP headers. So that's an issue. If you want to allow script to run, content to run from other domains on your page, cross-origin requests, you can allow them, but of course that would make you vulnerable, although you can specify which origins are allowed. So you have headers that restrict what you're allowed to do from other origins, and that's the more modern way to control this. So those attacks get a little baffling, but the examples in the Web Security Academy are easier to follow. Let's try the other Kahoot. Let's see. All right, what's the weak defense against clickjacking? Frame busting, where it tries to break out with JavaScript and it turns out to be pretty easy to overcome that defense. All right, so how do you steal a token with HTML injection? Add a second form tag, a form inside a form. That's the one I showed you, which I could not explain very well. I don't quite understand how it works, but apparently that's one way to do it. So what's the recommended way to stop clickjacking? Yeah, the X-frame options, the header is put there to stop people from loading your page inside another page, which is an essential part of the attack. All right, so which header field is something a browser adds to XML HTTP requests? The origin field so it knows where the request came from, and the server can decide whether it wants to allow a cross-origin request from that origin. All right, and which one is another word for clickjacking? That's UI redress.